In today's lecture, we will discuss about asymptotic notation. Asymptotic notation is used to describe the running time of an algorithm. Or in another word, we can say that it shows how much time the algorithm take to run if we give an input. There are mainly three type of asymptotic notation that are: first is big O. Big O, big O notation, that is its symbol is O and lesser than equal to. Another is omega notation. Omega notation, symbol is omega greater than equal to. And third is theta. Theta notation, its symbol is theta equal to. Big O notation, if we have two non-negative function and somehow we make right hand side greater than left hand side by using constant c, and there is also some n, and its reverse, that is somehow we make left hand side greater than right hand side, then that is omega. And theta is nothing but, if big O notation and omega notation both are following in the same given two function, then that is theta notation. We will discuss these in details. Okay, now start first, that is omega notation. In omega notation, if we have two non-negative function f of n and g of n. Okay, then we can write f of n equal to omega big O of g of n, if means if and only if. Okay, we can write this: if f of n is lesser than equal to some c dot g of n, where c for all n is greater than equal to n naught is greater than equal to 1, and c is greater than 0. If this condition is following, then we will say that the given two function are, that is f of n is big O of g of n. Okay, and naught and c are two constant, that f of n is lesser than equal to some constant dot g of n, and for all n is greater than equal to n naught. N naught and c is two constant. Maybe you all are not understand it in this time, but when we will discuss some example, then it will easy and clear to all of you. Okay, now we will see one or two example. Now take f of n as we will write this same thing in here, that I need some space to write example also. F of n is lesser than equal to c dot g of n for all n is greater than equal to n naught, and n naught is greater than equal to 1, and c is greater than equal to 0, and these are two constant. constant. Okay. Now take example. If f of n equal to n plus 1, n plus 5 or 1 anything, and f g of n equal to n. Now we will prove that g of n is greater than equal to f of n by using any constant c. Take n plus 5. Okay. Now greater than equal to, if we need to prove this, then we need to use some constant c and n. Now if we take c as 2, okay, now start from 1 and try to put in both side, and then find, we will get n naught. That n naught is nothing but that from that point, whatever the value we put in this example, then g of n will always greater than equal to f of n. Now take, we don't need to create this table again. This is the first example, so I am creating here left hand side f of n, g of n, and here value, and constant is c equal to 2 fixed. Now take n naught value. N naught value starting from 1. If we put f in 1 in f of n in the place of n, if we put 1, then its value will be 6 and its value will be 2. Next time put 2. When we put 2 here, g of n will be 4 and this will 7. Next, if we put 3, then its value will be 6 and its value will be 5 plus 3, that is 8. Now if we put here 4, then it will be 8 and 4 plus 9. F of n is 9. Now put 5. If we put 5, then g of n will be 10 and this will also give 10. So this way we get the value of n naught. Then when we put from n naught, g of n is always greater than or equal to f of n. Any value greater than 5, if we put in this example, then we will get that g of n is greater than f of n. Now take example 6. If you take 6, then it will give 6 into 2 12 and this will give 11. Okay, look, any value greater than n naught, that is here n naught value equal to 5, because in this value f of n and g of n is equal to, okay, so this is the n naught value, and any value from n naught greater than n naught we will take, then g of n will be greater than f of n. So this way for this example, c equal to 2 and n naught equal to 5. Okay, now we will take another example. Here we can write n plus 5 equal to big O of n. Okay, when c equal to 2 and n naught equal to 5. Okay, next we will see another example. Now we will take another example, that take f of n equal to n square plus n plus 1 and g of n equal to n square. Okay, Clearly that f of n is greater than g of n, but by using some constant we will make f of n is lesser than equal to g of n. Let's take find constant and also and not that and not as we discussed in previous example that and not is nothing but the lower limit or lower point from where the g of n will be greater than or equal to f of n, okay, by using some constant c. Now take if we need if you want to write this way, then we will need to find some constant c and not value, okay. Now take n square plus n plus 1, and if we want to write this way, then c dot g of c dot n square. Now take c as 2. You can take any value for c accordingly, then and not value will be changed. I am taking here 2, okay. Now try to find now we will find and not value that from where the right hand side will be greater than left hand side. In BIGO notation, our goal is make right hand side greater than left hand side any some any somehow we will make right hand side greater than left hand side by using some constant c, and we will find that point also, that from that point the f of g of n will be or right hand side will be greater than left hand side. Now find now again we will create a table. Now take here n value, n value, and here f of n and another is g of n, okay. Now for constant equal to 2, okay, take value 1. If we take n equal to 1, then it will give 1 plus 1 plus 1, that is 3, and it will give 2. Then take 2. If we take 2, then it will 4 plus 2 plus 1, 6, 7, 7, and here value will be 4, another 3, 9 plus 3, that is 12, plus 3 plus 1, 13, and here 18. Okay, here the value will be 8 because 2 square is 4, 4 plus into 2, that is 8, okay. So if we take so we don't need 3 also, because by using 2 as c as 2, and if we take n value as 2, then it will give 2 square 4, 4 into 2, that is 8, and here 4 plus 2 plus 1, that is 7. So from here, from n equal to 2, all the value greater than 2, if we put in this example, and we take c as 2, then g of n will be greater than f of n. So this way we prove that if we take c as 2 and n naught is greater than or equal to 2, then we will get, or we make right hand side greater than left hand side. So here value will be, we can write n square plus n plus 1 is big O of n square for all n is greater than equal to n naught. This for n equal to 2 we get, or we make g of n greater than by using c, by using constant c, greater than equal to f of n. So here n naught will be 2, n naught will be 2 and c equal to 2. Okay. Now we will take another example. If f of n equal to n plus 5 and g of n equal to n minus 5, then we need to find and if we want to write in this way, that is f of n is big O of g of n, then we will need to find some c and also n naught. Let's take n plus 5 is greater than equal to c, some constant n minus 5, and c. If we take c as 2, then we need to find n naught. That n naught is the point from where the f of n is lesser than equal to g of n in the presence of some constant c. Here constant, I taken constant as a 2. You can take any value, accordingly the value of n naught will be changed. Okay. Now take try to make and we don't need, in previous 2 video I create table. If you need, you can create your own. I'm directly here discussing. If n value take n value as 1, then its value will be 6 and its value will be n equal to 1 minus 5, that is minus 4 into 2, that is minus 8. But here we have to make clear that no any function give negative value, and we don't want to take any value that will give negative. So we will take some value which is greater than 5, because any value less than 5 or any value which is less than 5 or 5, then its value will be 0 or negative. So we will take in n greater than equal to greater than 5. Okay. Then take n 6. If n value equal to 6, then its value will be 11 and its value will be 1 into 2. So this is not hold good. So we will increase n value. If n value equal to 9 plus 5, that is 14, and 9 minus 5 4 into 2, that is 8. So n equal to 9 is also not hold good. So we will take another value, n equal to 12. 5 plus 12, that is 17, and here 12 minus 5 7 into 2, that is 14. It is also not hold good. Then we will take n equal to 15. Then if we take n equal to 15, then it will give 20, and it's 15 10 into 2, that is 20. So less than any value, if we take any value less than 15, then this we can't write f of n is big O of g of n, because from less than 15 the value of f of n is greater than g of n. If you want, take 14, 14 plus 5, 19. Here 14 minus 5, left hand side is 19, and 14 minus 5, 9, 9 into 2, 18. So this is not possible. So we will take n not as 15, and any value greater than 15 will give g of n is greater than or equal to f of n. Take n value as 16, 16 plus 5, 21, left hand side 21 and right hand side 16 minus 5, 11, 11 into 2, that is 22. Okay, so for this example we can write n plus 5 equal to big O of n minus 5 for all n is greater than equal to n naught, and n naught will greater than equal to n naught equal to 15 and c equal to 2. So here n naught is the lower point or lower limit. From that point the value of g of n is greater than equal to f of n. So in this way we can say or prove that n plus 5 is big O of n minus 5 when n naught is equal to 15 and c equal to 2. Thank you. If you have any confusion, then write on comment box. Thank you.